Hello, everyone. I thought before we begin lab number one, I'd take some time to discuss, what is the heartbeat, what we really sort of want to think about is this thing called the periodic table of elements. Um, what our not the knowledge we need to have to be able to deal with it is very slim and none. You don't need to have a chemistry background. And if anyone viewing this right now has had a course in chemistry, immediately just skip this video and go right into the labs. It's not going to be that difficult whatsoever. But if you haven't had chemistry before, why don't you stick around and let me explain a few things, a few very simple things that'll make this lab just fly and go very easy for you. Okay, so right below this video, I have an image, which is the periodic table of elements. So really, of the 103 things that you're looking at there, you see all those little things, those little cubes you're looking at? That's the entire universe. That's it. That's all the universe is made up. It's just combinations of those 103 different things. I don't care. And you too. There's nothing in you other than, not even that much. In fact, you stop. Oh, pretty much just about the number 30. That's about it, maybe 1 to 30, and some admixture of those, and that's it. That's what you are. So what you're really looking at is the universe. So if you think the universe is complex, it's really not, and neither is his chart. Let's have a look at it. So we look at the building blocks, right? So we can figure out which one's number one. You look up at the left-hand corner at the very top, this thing called H. It's a hydrogen, right? Okay, so let's find number 2, right? So over the other side of the chart, you see this thing called helium, right? Now let's go back across. What it does, it goes up in number, and then you go back again, it goes up in number again, it goes back, it goes up in number. So see the pattern? 1, then goes to 2, then it goes over to 3, 4, 5, 6, 7, 8, 9, 10, all the way across, then back to 11 and cross, okay? So as these numbers going up, they're really significant. What they're signifying is these things, these molecular things called atoms, are just getting bigger. So from number 1 to 103 is really a size chart. The things are getting bigger. But we got to figure out what they're getting bigger in. Right? And this is the stuff that makes chemistry so simple. So you have hydrogen in there, number 1. So what is number 2? Well, if you take 2 hydrogens and you put them together, essentially you've got number 2, helium. Right? So what if you want to get number 3? Think called Li, lithium? Well, you just add another hydrogen to number 2, and you get lithium. So lithium is really 3 hydrogens. So what if you want to get number 4, beryllium? Well, you add another hydrogen to number 3, and you get a beryllium. So what if you want to go over and get a boron, number 5? What do? Well, you add another hydrogen to beryllium, and you get number 5. What if you want to get carbon? Well, you add another hydrogen to boron, and you get carbon. But if you want to get a nitrogen, number 7, well, you add another. I think you see the pattern. Really? That's it. You just keep adding hydrogens, and these atoms get bigger and bigger. And it's just the different combinations of their sizes and the properties which make everything around us, right? So this underlying simplicity, creates the overwhelming complexity. That's why we stay with the underlying simplicity. I don't want to get lost in the complexity. And if we just stay with this, things begin to really make sense, okay? Now, this is a periodic table in a very simplified form. There are other forms where all these other numbers that are involved that explain a lot more about the inner workings of these things. But you know what? I don't know about you, but when I get in a car, I just like to drive it and see what it drives like. I'm not too worried about getting underneath the hood. And that's what we're going to be doing. Each one of these things are like vehicles. We just want to drive it and see what it does, not get underneath the hood. It's not going to help us, right? It's not. Okay. So, when I look at this periodic table, I can see it very simplistically like that because that's really the way that it is. And what we're going to be trying to figure out are which combinations of those blocks you see, those numbers in there, with those elements in there, make us. And why those? Really what is it about those numbers? Which ones that make it special for life? And which are impossible for life? And for what reasons? So the first thing when we talk about anthropology, we got to get down to the basics, what we are, what we're made of, and what makes us actually run. And exactly how similar are we to all the other life forms? Well, right off the bat, I'll tell you that we're all based on the same basic combinations of elements we're going to be looking at in lab number 1. And we're just going to be looking at some of the basic properties. And I can help you get more familiar with about some of the basic shapes that these things actually produce too. All right, so let's get going on that lab. And this is the one where people get nervous at, and that's why I'm always here for you. Your phone, that phone, anytime you're lost, bam, hit me up with it, okay? So this is really, chemistry is one of my specialties, and I'm going to say something about this. I started out as a chemist until I realized that it was ridiculously simple. I'm like, I'm just not going to do this for a living, right? And maybe I shouldn't have thought that because I didn't realize what that chart could actually tell me about myself. And as I became an anthropologist, I realized, what it was trying to tell me about the coherent whole life is, right? Telling us that everything around us is in this thing together. And that perhaps while we call life, different species, maybe it's not that we're different species. We're just different sort of nodes off the same tree, and that whole tree is alive, right? And it may even help us conceptualize what we are as part of a greater life itself, which might be the actual organism. I think this chart might actually help us with that in understanding it in lab number 1. Okay, so have a look at this, get familiar with it. Now, next thing I want to say before I go is that when we go into the lab, I'm going to add just a few things to what you're looking at here. And what it's going to say is this, is that there's some properties, some really unique properties about, you see where the columns are that everything lies in? What's interesting is everything, like over here where hydrogen is in that one column, column 1, they kind of behave similarly. It's being in that column is special. Then, so is the next column, being on where beryllium is number 4. Everything that goes down there, being just in that column, there's something special about you. All the way over, even where you see carbon, being in carbon's column, there's something special there. Being in nitrogen's column, all the way down number 7. So, all those columns which you see, there's something special about. So in the labs, I'm going to have, these columns marked out with the numbers. Our job is to sort of figure out, maybe like carbon, which you've heard is the heartbeat of life. But what's special, about being in that column where carbon's at? And maybe what's even special about being in that row? You see, because carbon's not at the very top, it's the second row down. Maybe there's something special about that row. So think in terms of what's special about columns, what's special about rows, and then we're going to try to hone in on really what makes life possible. And I think we're zeroing in on that big number C right there. Carbon is our goal. All right, so I get started on this, and I'll help you as you proceed.